Welcome to everyone. Today we are going to discussing about the another important topic on computer network, which is scheduling mechanism. So, as we discussing in the previous sessions, while we maintain the quality of services value, we have to understand the flow mechanism value. So, if you understand the flow characteristics value or flow mechanism value, we have to understand the what is kind of jittery mechanism is there, right? And what kind of reliable services is there, and what kind of bandwidth they are using that one. So all these things are important to maintain the flow control value, which apparently depending upon the quality of services. If the flow control is very well, the information transfer accurate, so efficiency is very good, then the quality of service apparently improved. If not, if any issues are there, the bandwidth issues or data granularity issues or reliability issues or jitter issues or congestion control issues, the flow control is mismatched. So it obviously impact on the quality of services. So down the line, we have to understand the hierarchy level, what is the bandwidth and what is the importance of every parameter flow control, how will shows impact on the quality of services. So to maintain the quality of services, we have to follow the things we calling as a scheduling and queuing mechanism. We calling as a scheduling mechanism as well as a queue mechanism. So while coming to here, what is scheduling mechanism? So if any packet information is there, the packet is transmit data from different network, it will be multiplexed or queued. So that should be in the form of this buffer state to transmission for a link. For example, here we have two autonomous systems there. So information is transmitted from different networks are there. We have multiple complex situations, multiplexing situation we are using that one, and these are in the form of this queue manner only. So that should be in the buffer state values only to transmission of information in the form of the link. So that kind of things we calling as different kinds of queuing methods we are using that one, that we calling as FIFO, apparently we calling as a first in first out, and priority queuing and WEFQ we calling as a weighted fair queuing. We have three mechanisms are there, which is first in first out, which is FIFO, second is priority queuing, third one is we discussing about weighted fair queuing. So what is this first in first out? So when you see the architecture of this one, in the first in first out, the name itself is there. Who are getting the first value? That should be comes to the first out. So for example, the information is transmitted. Information is transmitted from source to destination is there. So we have to maintain the some kind of architecture values based upon channel density value. For example, I'm having 10 different channels are there. So the information is continuously getting information from some of the network. So we have to choose a path. We have to give the respective tokenization path values only. So this channel is busy. So we simply put in the discard position. Right. So when you see this one, when the arrival rate, n number of arrival rate is getting faster, fast arrival rate or n number of information is transmitted continuously manner. Continuously manner, n number of information is transmitted from different networks or different autonomous systems. So we have to check the conditions of my queue state values only. If the queue state is in free state, if it should be full of value, the state is free state, then we put it into the queue manner, right? Or else if this queue is busy, engaged value, it should be simply discarded unless queue should be ideal position only. So if this situation is ideal value, these are free value, these are busy state value, this will move into the departure value. We have to process the value and information transmit to the destination state. So unless these are in busy state, we discard it. If the queue state is available, if a number of channels are available, we entering into the domain, and in the who are getting the first one, packet is first one, that should be released in the first out values only. For example, I'm transferring frame 1, frame 2, frame 3, so on till frame 10. So the frame 1 is arrived. First we check the condition. The queue is busy or free. So the queue is free. So this frame 1 is occupied the first position. Similarly moving to frame 2. Again check the condition, full or not. If full, discard it. If not, frame 2. Similarly frame 3. Similarly so on, frame 10. So frame 10 are done. Next we transfer the frame 11 is there. So you check the condition, whether it is n or y. If it is n, merge that one, embedded to 11. Right. If it is only 10 channels are there, but 11th frame is getting, simply discarded the frame. So what happened? The frame is processed, this is been successfully delivered. Right. So here what happened? 2 has come to this position, 3 has come to this position. What happened? On the 10 is in vacant. So 11 is comes to in this picture. Again we have to retransfer the process, 11 is come to this picture. So this kind of queue kind of architecture, the mechanism, that kind of process we are calling as a first in first out mechanism. And next one is we calling as a priority queuing. So what is priority queuing? So in the name itself is there, we calling as a priority level. Right. The name itself is there, we calling as a priority level values only. Now see this one, any n number of frames are arrival from the next value. We have to classify situation is there, because we call it as priority queuing. Basically we have to understand the importance of that one. Right. We have to classify queuing is there. If the classifier is full state, should be higher priority value or else lower priority. Two things are there. The classifier, two things are there. Very higher priority or else lower priority. So you have to understand the classifier section, whether it is the urgent basis or else it even transfer information slow manner as well. So classifier has to decide that one. If it is the highest priority, move information to this section. If it is in available mode, it will process the thing. Or else if it is simply discarded. So it is more or less similar to first in first out, but we have this advantage of this prior queue. In the previous one, what happened? So based upon the first in first out mechanism, who are getting these first services, who are occupying the first channel, the information is transmitted. The second, next, third. But in the what happened? Out of this one, 10 will get this highest priority. So we have to wait after completion of 9, the 10th term is come, then information is transmitted. But here what happened? Based upon the priority level, the classifier has to decide that one. The 10th is the highest priority, it choose the queue value structure. Or else it move to the next stage, which calling as a low priority. If highest priority channel is possible, it will process information, then there should be departure. So here what happened? A switch turn should be happen. This kind of switch turn should be happens other queue where current is empty. For example, this is a empty stage. All the things are transmitted. This is moving to this is. If this is done, moving to this one. It should be the vice versa model. So that we calling as a priority queuing. Next one, weighted pair queuing. So what is weighted pair queuing? So the name itself is there. So based upon the weightage values, based upon the weight structure values, for example, see this one, weight 1 is there, weight 2 is there, and weight 3 is there. For example, here 2 frames are empty, here 3 are empty, here more than something are empty. So based upon the classifier has to understand the weight molecule, weight precautions value, weight pair queuing value, information is transmitted to either frame 3, frame 2, next frame 1. So again here, so this is full discarded. If it is not, should be forwarded. So once it's forwarded, he has maintained one kind of a motor of things, one kind of structure kind of architecture. So if it turns the switch select, the 3 packets for the first queue, next 2 packets from the second queue, next 1 packet from the third queue. It should be handled in the cyclic kind of manual values only. Then it should be processed and then information is departure. That we calling as a weighted pair queuing mechanism. And next one we discussing about is policy. So what is this policy and how it is helpful for us? So in the policy mechanism, the network monitoring mechanism, network traffic flow is continuously ensure that one, because that may need the traffic contract value. So network is always monitor the situation, what kind of traffic density is there, information is transmitted from source destination. We have to ensure that value. We have to maintain the traffic contract value. So when this packet is violates the contract, which means this packet is discarded thing, network is discarded or is tagged to the next packet mechanism, that should be acting as a lower priority. Unless if congestion occurs, that packet is discarded first. Which means we have to understand the packet situation, whether packet is violating the contract, so network is discarded or tagged into the other packet based upon the lowest priority level or highest priority level. Or else if congestion happens, the simply discarded, we initiate the retransmitter. So how it happens? Based upon the leaky bucket algorithm. So based upon the leaky bucket algorithm or token bucket algorithm, we have to handle this policy mechanism. So in the policy mechanism, the bucket has a specific leak rate for every contactor rate. The bucket having as a leak rate for every contactor rate, average kind of contactor rate. And this bucket has specific depth accommodate variation arrival rate. This bucket having as a specific depth in accommodate the variation in arrival state. And so this may cause the advantage of us. And this arriving packet is confirmed. It does not show the result. It may having as a overflow, right? So the packet is confirming, but information transmitted. If does not have any result, it may cause the overflow. So another method we calling as a shaping mechanism. We calling as a traffic shaping mechanism. So what is shape mechanism? We have to shape the traffic before enter the network, which means we have to understand the traffic density value. We have to leverage the value, so to understand the density of the mechanism. We have to get one kind of shape value, then only we can able to control the congestion value that we calling as traffic shaping. So traffic shaping can control either the rate at which data should be transmitted, because we have to either should be control data rate value, or else the either we should be increases or decrease the data rate value before it transmitted, which is generally used in the ATM or integrated services network. So at connection time, it means setup time, the sender and carrier should be negotiate the traffic pattern. We have to understand we have to adjust the traffic density value based upon how to control the data rate value. So we have to negotiate the traffic pattern between the sender and carrier negotiation. So here two types of traffic shaping algorithms are there. One is leaky bucket one and the one is token bucket one. So handle the traffic kind of structure, traffic mechanism, we have two things are there. One is leaky bucket algorithm and the other is a token bucket algorithm. So while I conclude this session, so in this session we are going to we discussed about two important topic, which is scheduling mechanism and as well as queuing mechanism. So while seeing this one, in the scheduling mechanism, right, in the scheduling mechanism we are discussing about three important things. First one is first in first out, priority queuing, as well as weighted fair queuing. So here what happened when discussing about each and every mechanism, so either should be priority value or as weighted pair queuing or as FIF mechanism. So here every case certain advantages there, certain limitations are there. We can't say disadvantage, but we can able to say some kind of limitations are there. For example, go for first in first out, we are not bothered about this the priority level. So at the same time in this one, the weighted pair queuing or priority queuing, we are choose the priority level. So we have to overcome here into the priority queuing. And similarly in the weighted pair, so here in the rotation manner, the weighted 1 send 3, weighted 2 send 2, weighted 3 send 1, that kind of weighting kind of mechanism we are using that one. That come to the scheduling policy. And similarly in the queue mechanism, the queue kind of structure information is transmitted. Both are apparently similarly, so emerge one by one to information is transmitted. So here to take in this one, we have to maintain the some kind of architecture algorithm that we calling as a leaky bucket algorithm as well as token bucket algorithm. So in the upcoming sessions, we are going to discussing about the in-depth of this, what is leaky bucket algorithm and what is token bucket algorithm. So while information is transmitted from source to destination, for example, here one source is there and one destination is there. So how the information is transmitted while I am using this kind of token bucket algorithm with help of this scheduling mechanism is involved, as well as the policy mechanism involved and queue mechanism involved. So we have to understand the mechanisms of all these things, and those are emerging into this bucket algorithm, which we calling as a traffic shaping mechanism value. So based upon this traffic shaping mechanism value, then we have to include that, we have to emerge this one, a leaky bucket algorithm as well as token bucket algorithm. Thank you.